Hey folks, today's topic is derivatives using trig rules. So this isn't like you have to do with the power rule. There's no like work that has to be done. I mean, just literally whenever you want to derive sine, it's just cosine. The derivative of whenever you have to derive secant, it's secant tangent. So there's not like a derivative shortcut here. When you're deriving the trig rules, you just derive them according to these rules. And if anybody's interested in why this is true, I could prove it to you. Be happy to show you, but I'm not going to use that right now for notes. So let's start deriving. So we've got our function y equals sine of, or 2 sine of x plus 3 cosine of x minus 4 cosecant of x. So if I want to find the derivative, that would be y prime equals, now this 2 is just a constant, so that means it's going to be part of my derivative as well. The derivative of sine, I look up above, the derivative of sine is cosine, so I get 2 cosine of x plus 3. Then I look up above, the derivative of cosine is negative sine, so I'm going to rewrite this as negative sine of x, minus 4 times the derivative of cosecant. I look up here, the derivative of cosecant is negative cosecant x, cotangent x. So when you derive a trig function, you just take out what the function is and replace it with its derivative. Now, I would expect you to clean this up. Let's see if we can put some stuff together. Y prime equals 2 cosine of x is as nice as it's going to be. 3 times a negative 1, right? That's a negative 1 coefficient, so I can put those together. That would be minus 3 sine of x. And then we've got the same thing here. A negative and a negative make a positive 4 cosecant of x, cotangent of x. So there's the basics. There's the sort of fundamental idea. Of course, it gets a little bit more complicated and a little trickier, and we're going to get into that, but that's the basic idea. So if I want to derive this function, 2/9 x to the 6th minus secant of x, this is just, we're adding the trig rules to our arsenal of derivatives. So we already have the power rule. Now we have trig rules. Next, we're going to do the product and the quotient rules. So I'm going to start to derive this, f prime of x. What's the derivative of 2/9 x to the 6th? Well, that's a power rule. So I would take the 6 and I would multiply it. Now, what I'm going to do in my head is I'm going to reduce the 6 and the 9. They both are divisible by 3. So when I cancel out, there's going to be a 2 left on the top. So 2 times 2 is 4. There's going to be a 3 left on the bottom. So this becomes 4/3. And then I take away 1. That's the power rule that we've been doing for a while. Minus, now the derivative of secant, I don't know what that is, but I can go look it up. Derivative of secant is secant tangent. I'm going to take out this secant. I'm going to replace it with its derivative, which is secant x tangent x. What do you think? Now, if your derivative is not set up to use these rules, then we got to do some of those moves that we did back in Unit 7. You remember the trig proofs, where we take secants on the bottom and flip them to the top, or rewrites things as sines and cosines, and we look for squares? That's what we're going to do here. So I'm going to see if I look at this and I say, do I like it or not? As I look at this, 5 over x squared is not something that I like, so I'm going to do a rewrite. So I have f of x equals, the cost of bringing this from the bottom to the top is you make it a negative exponent. Now over here, cotangent, I have a derivative for cotangent, but that's just cotangent, not a cotangent on the bottom. So what I'm going to do is I'm going to take the cotangent from the bottom, I'm going to move it to the top, just like I did with this x. But the cost of moving an x squared from the bottom to the top is a negative exponent. The cost for moving cotangent from the bottom to the top is to turn it into its reciprocal. And if you might remember, if not, you can look at your unit circle. The reciprocal of cotangent is tangent. So the big idea here is if you've got a trig function on the bottom, you can move it to the top as long as you turn it into its reciprocal. Now I have two things that I can apply my derivatives. I can do the power rule with 5x minus 5x to the negative 2. And then I have, they told me up above, I have this thing that derives tangent. So f prime of x would equal, multiply would be negative 10, subtract 1 would be negative 3. This 3 is just a constant, so it's just going to be out front. The derivative of tangent is secant squared. And there we go. Now, because this is calculus, you could stop here or you could clean up. I would say I'd clean this up because it's so easy to clean up. I would bump that cubed back to the bottom. But like I said, you wouldn't have to. Unless it was a multiple choice and your answer doesn't look like their answer, you'd have to clean it up so that you could compare solutions. Now, the last one I want to show here is just reminding you that 99% of the time when we have fractions, we usually want to put them together. So in other words, if I had, like, let's say, do a little margin work here. If I had x over 3 plus 2 over 3, we would rewrite that as a common denominator of 3, and x plus 2 ends up being x plus 2. Now, most of the time, we want to go this way with our fractions. We usually want to take them apart and put them together. Yes, that is true. But sometimes it's actually better to go the other way. If you have an equal sign, it's equal from both sides. So what I can do is I can take a fraction that's together and I can also split it apart. Watch what happens when I do that here. So I get y equals, and now I'm going to split these apart into sine of x over sine of x plus cosine of x over sine of x. They still have a common denominator, and I could put them back together if I wanted to, but now this thing will clean up. Now remember, this is still y. This is not the derivative, so I'm not going to write y prime. What's sine over sine? Well, anything divided by itself is 1. Plus cosine over sine is cotangent. Now, I know how to derive 1, and I know how to derive cotangent, so I can finish this off. Y prime would be equal to the derivative of 1 is 0. The derivative of cotangent is negative cosecant squared. All right, so there you go with your trig derivatives. Now we can add those to all of our tricks, and then when we come back next time, we'll start looking at this thing called the product rule. Good luck.